Today we are going to discuss the mean and the standard deviation of random variables. A random variable is a variable whose value is a numerical outcome of a random phenomenon. Basically, we have two types of random variables. The first one is called a discrete random variable. And the next slide will discuss continuous random variable. For a discrete random variable, the x has a finite number of possible values. The possible values must be finite. Right? The probability distribution of a random variable x lists the values and their probabilities. For example, the value of x can be x1, the first one, x2, x3, and all the way, for example, to xk. We have k possible values for random variable capital X. And the corresponding probability is, for example, for x1 is p1, for x2 is p2, for xk, the probability is pk. And we know the probability pi, I equals 1, 2, 3, 4, all the way to k, must add up to 1, because the total probability must be equal to 1. The probability of any event is the sum of the probability pi of the values of x that make up the event. For example, if we ask what is the probability of event A, where event A include only x1 and x2, then because this event includes this x1 and x2, then the probability for event A will be the sum of p1 and p2. Here we have two examples. The first one is very easy. A coin was tossed twice. What is the probability to have at least one head? Okay, so we have a coin and tossed twice. The first time maybe head and maybe a tail. And the second time, so also maybe a head and maybe a tail. So the total possible value, possible outcomes for this event is head, 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 tail, tail, head, and tail, tail. Okay? So HH, HT, TH, and TT. So HH and HT, TH, and TT. So we have 4 possible probabilities. Now, this is a discrete random variable. The x is the number of head. The number of head. So x can be equal to 0. That means no head. Or can be equal to, okay, let's move to here. The x can be equal to 0, no head, can be equal to 1, 0, 1 means no head, 1 means only one head, maybe this one or maybe this one, and 2 means 2 head, and we don't have any other possible values. So this is a random discrete random variable. We have finite number of possible values, we have only 3. And we need to list the possible probabilities. What's the probability for this x equal to 0? That means there's no head. Looks like no head means that's tail, tail. So definitely this one has only one, occurs only once. And how about there's only one head? So this one and this one. So we have 2 times, twice. How about head, 2 head? So again, there's only 1. So the proportion for this one is 1. Proportion for this one head is 2, and 2 head is 1. We are asking what is the probability. The probability for this one, because we have totally have 4 possibilities. So the probability for this one will be 1 over 4. The probability for this one is 2 over 4. The probability for this one is 1 over 4. So this gives us the probability distribution. Probability distribution. We list, so this is pi, this is xi, x1 equals 0, x2 equals 1, x3 equals 2, p1 equals a quarter, p2 equals 2 quarters, and p3 equals 1 quarter. So this gives us this table. It's called probability distribution. Now the question asks, what is the probability to have at least one head? This is the event. We said this is the event. For example, we call this event A. And the event A, the probability for event A will be the sum of all the probability that make up the event. The event is at least one head. So that means can we have one head or two heads? So there are two probability made up this event A. So this one and this one. So the probability have at least one head will be equal to the first one, 2 over 4 plus 2 head, this one, so equal to 3 quarters. Right? So this is the first easier problem. Okay, next problem is a little bit difficult. A coin was tossed 5 times, and that's twice, this is 5 times. What is the probability to have at least 3 heads? Definitely we can follow the same steps, do like this, but you are going to find out this is very lengthy. It's not easy to do this. So we do not use the same method. We are going to have a better way to do this. Okay, before we discuss the new method to calculate the probability to have at least 3 heads, we want to mention or review a concept. It's called combination. Combination. Combination is, for example, in our class we have 35 students. I want to choose 2 to make a team to do something. So how many options, that means how many ways I can choose these 2. Here, the order doesn't matter. For example, if I choose student A and student B, or I choose student B and student A, then there's no difference because either way, it's student A and B. So if we do not consider the order, that is a combination problem. If we consider the order, that will be permutation. So in this class, we do not discuss permutation. We need to use the combination concept. Okay, so here, we use this one. I think. Suppose we have a 3 student. If I choose 1, how many options do I have? The total is 3. If I choose 1 as a team, then we know I have 3 options. So that one will be equals 3 options. Now, still, if I choose 1, then I have 3 options. If I still total 3, if I choose 2, how many options do I have? This needs a little bit longer to think, but the result is the same. I still have 3 options. The reason is, for example, student are A, B, C. I can choose AB, I can choose AC, I can choose BC. So I have only 3 options. AB, BA the same, BC, CB the same, and AC, CA the same. So I have only 3 options here. How about if I choose 3? I have only 1 option, so that is 1. How about I choose 0? 3, I choose 0. That means I do not choose anyone. Again, I have only 1 option. That means I choose no one. This is easier to think because the number is small. How about if I have 30 students, or like 35 in the class? If I choose, for example, 10, how many options do I have? Then I cannot think like this. We need to have a way, a method to calculate this. This is a combination. For this one, how to get, if I choose 0, how to I get 1? Right? That is, we write like this one. 3 choose 0, that equals 1. Right? How about the second one? Second one is from 3, I choose 1. Right? Again, parentheses, 3 on the top, 1 on the bottom. So 3 choose 1, right? We know the result equals 3. Right? So that equals 3, this one equals 1. How about this one? So 3 choose 2 equals 3. And 3 choose 3, okay, that one equals 1. Okay, basically we have a formula. Like if I have n, I want to select k, I will write like this. From n, I select k. And how to calculate this? We know for this smaller numbers equals 1, 3, 3, 1. Okay, so this one equals n factorial divided by k factorial and n minus k factorial. N on the top, n on the top. K on the bottom, k on the bottom. And the difference, n minus k factorial. Here usually k is larger than, n is larger than k, because we select k from a group of n. So n is bigger than k. Factorial, right? Factorial means, for example, if I said 3 factorial, that will be equals 1 times 2 times 3. Okay? How about 13 factorial? 30 factorial. 30 factorial will be equals 1 times 2 times 3 times 4 times 5 and all the way to times 30. And definitely this 30 factorial is a very large number. Okay? So 3 factorial equals 6, 4 factorial equals 24, 5 factorial equals 120, and 6 factorial equals 720, and 30 factorial equals all this. That's a very large number. But anyway, we have ways to calculate this combination. The physical meaning for this combination is n select k. If you know MATLAB or any other software, they may have functions called n select k. And in this class, I want you to calculate this number. Usually, I give you some small numbers, or even if big numbers, we have a way to calculate this by cancellation. But anyway, we need to know how to calculate this. Okay, so here now, once we know this, we can go back to this problem. Okay, for simplicity, I still write here. So n choose k equals n factorial over k factorial n minus k factorial. For you to see this. Now, for this one, I have 5 probabilities. So actually, I will have like 1, 2, 3, 4, 5. These 5 spaces blanks can be H, can be any H or T. Here, H or T, H, T, H, T can be any combinations. So basically, we can see we have 32 combinations. This one has 2, this one has 2, this one has 2, this one has 2, this one has 2. So 2 times 2 times 2 times 2 times 2. So we are going to have 32. So 2 to the 5 equals 32 possible outcomes. And we want to know the event is at least 3 head. That means 3 head and 4 head and 5 head. So this event consists of 3 situations. The first one is we have 3 head. The next one we have 4, and we have 5. So how to calculate the probability to have exactly 3 head? We know the total equals 32 here. Right? Now we have these 5 spaces. So I have 5 here. I choose any 3. I select any 3 to be a head. So that is 5, select 3. So that is the total possibility that we have 3 head. And for 4, same thing. We have 5, we choose 4, this one. And for 5, also we have the same thing, 5, select 5. We know the total equals 32. 2 to the 5 equals 32. Now, what number is this? We are going to use that formula to calculate this. 5 factorial. So 5, select 3 will be equals to 5 factorial over 3 factorial, then over the difference, 5 minus 3 equals 2 factorial. Look at this. This one equals 1 times 2 times 3 times 4 times 5. So on the top, that will be 1 times 2 times 3. So that one will be equal to, I write here, right? 1 times 2 times 3 times 4 times 5. And here, 3 factorial means 1 times 2 times 3. And this 2 factorial means 1 times 2. Alright, so we can cancel this 1, 2, 3. So on the top, we have 20 left. On the bottom, we have 2 left. So the result, this one here will be equals 10. Okay? What I want you to write is, you write as 5 factorial, 3 factorial, and 2 factorial. Okay, that equals 10. How about this one? 5 over 4. 5, select 4. So 5 factorial over 4 factorial, then over 5 minus 4 equals 1. So 1 factorial. We know 1 factorial equals 1. 5 factorial equals 1 times 2 times 3 times 4 times 5. And this one equals 1 times 2 times 3 times 4. So if we cancel these 2, we have only 5 left on the top. Bottom this equals 1, so that one will be equal to 5 factorial, 4 factorial, and 1 factorial. Okay, that equals 5. For this, on top equals 5 factorial, on the bottom also 5 factorial, then the difference equals 0, and the definition is 0 factorial equals 1. 1 factorial equals 1, 0 factorial equals 1. So this one equals 1, okay, 5 factorial, they cancel, and then nothing, so we have only 1 left. Okay, now we know the total number for possible outcomes is 32. So the probability for this will be 10 over 32. So this one will be 10 over 32, then plus 4 head will be 5 over 32, then 5 head will be 1 over 32. So the total will be 10 plus 5 plus 1 equals 16. 16 over 32, so equals half. So the result will be equals half. Okay? So this is an easier way, a more systematic. We don't need to write all the possibilities. We just use these formulas to calculate this. You need to understand this formula and also the physical meaning when and how to use this formula, because later time we still need to use this formula a lot of times. So we need to be able to use this. Okay, so this is finished the discrete random variable. The next slide will be continuous random variable. Continuous random variable x takes all values in the interval. In the discrete, this x can only be finite values. And this here, x can take all possible values. How do we assign probabilities to event in an infinite sample space? We have basically 2 methods. The first one is use density curve and compute the probabilities for the interval. And the second is the probability of any event is the area. Okay, here we know this area and the density curve. We are very familiar with this in our previous chapters. For the value of x that make up the event. The probability of a single event is meaningless for a continuous random variable. Only intervals can have non-zero. Only intervals can have a non-zero probability represented by the area and the density curve for the interval. Up to this point, you may remember we have an example, homework example before. I asked what is the probability of the proportion or the probability that someone has exactly 1,200 Facebook friends. That example, as I mentioned in the discussion section, is not a very good example, right? Because we know the friend can only be 1, 2, 3, 4. So that is not continuous random variable. But the assumption is this friend can be very large number. For example, 1 million, 10 million, 1 million or 10 millions. So we will approximate that distribution as a continuous distribution. So for the proportion to have exactly equals 1200 friends will be, that is a single event. The meaningless means the area, as we mentioned, the area equals 0. So that probability or that proportion equal to 0. I know some of you already calculated by a lot of method. I use 1199 and 12 and 1 and subtract or something. As I said, this is not a very good example, but we try to understand the difference. We approximate that with a continuous random variable. So now we understand that for continuous random variables, if we want to calculate the probability or the proportion as in previous chapters, we are going to calculate the area under the curve and within that interval. If the area equals to 0, then the probability will be equal to 0. The shaded area under density curve shows the proportion. That proportion, that concept is what we used before. So from this chapter and following chapters, we are going to use a probability. The individuals in a population with values of x between x1 and x2, because the probability of drawing an individual at random depends on the frequency of this type of individual in the population. The probability is also the shaded area under the curve. So the probability is also the shaded area under the curve. The next, we are going to use an example to discuss what's the difference between the proportion and the probability. So for example here, what is the number of individuals with x such that x greater than x1 and less than x2? That is a proportion. And this probability is greater than x1 and less than x2. So they are the same thing. They use the same method to calculate this. That means we're going to calculate the z-score for normal distribution and use table A to do it. For normal distribution of many random variables, the probability distribution for many random variables is a normal distribution. That's why we emphasize a lot in this class, the normal distribution. We are going to discuss some other distributions, but the most important one of the most important tool is the normal distribution. It shows that what value the random variable can take and is used to assign probabilities to those values. And to calculate the probabilities with a normal distribution, again, for normal distribution, we can use z-score. For other distributions, we don't use the concept of the z-score because there's no z-score for other distributions. And we are going to use table A to do this. Example, the probability distribution of a woman's height as a normal distribution. Here, since we choose a woman randomly, we choose only one. We do not discuss proportion anymore. We choose only one person randomly. Okay, her height x will be a random variable. Right, so here we have the example to do this. What is the probability if we pick one woman at random that her height will be some value for x, for instance, between 68 and 70 inches? The probability for the random variable x to be greater than 68 and less than 70. Recall what we discussed in previous chapters. What we asked usually said the proportion. This again is the height normal distribution. We are going to ask what proportion is of the whole woman population that their height is between 68 inches and 70 inches. What proportion? Now the difference is we only randomly choose one. Choose one. The one we cannot discuss proportion. Instead, she may be within this range or maybe out of this range. So there's a probability for this random woman to be as high within this range. So that's why we said we calculated the probability. And this P means probability, not the proportion anymore. Proportion means a lot. Probability means it refers to only one person. But the method is still the same. Because the woman is selected as a random x is a random variable, that is what we are going to discuss in this chapter. Okay, so what we do is as usual, we use z score. So z for 68 equals this is x, right? Okay, this is the x minus mu x bar, and this one divided by standard deviation. The normal distribution still we use the previous numbers. The mean of the normal distribution equals 64.5. The standard deviation equals 2.5. So the z score for x equals 68 equals this minus this over this. This is x. Then equals 1.4. And corresponding to another one, x equals 70. This is x, and this is x. This is mu, and this is standard deviation, and that one equals 2.2. Usually, I suggest you to draw a rough approximate distribution like this, and this z equals 1.4 corresponding to the original 68, and this z equals 2.2 corresponding to x equals 70. And what we are looking for is before we are looking for the proportion of this side, this area, and now we are looking for the probability of this. So, but either way, we are looking for the area of this shaded part. Now you should be very familiar how to do this. We use table A. Table A for z equals 1.4. Okay, that gives us the area from here all the way to the left, and that area equals 91.92. And the area for this give us, you look up the table A, and for this score equals 2.2, and we found that that number equals 98.61, which gives us the area from here all the way to the left. And we subtract these two, we get the distance, or the difference of this gives us the probability for the random woman to be as high as the height between 68 and 70. So that equals 6.69%. Okay? We emphasize you need to know how to calculate the z-score, how to check, how to use the table A. If you already know this, I believe most of you, more than 90% of you already know, are very familiar how to use that. Now there's not difficult at all. This is the same thing. Next, we are going to discuss the mean of a random variable. We just discussed the discrete random variable and continuous random variable. So we calculate the mean. First, we calculate the mean of discrete random variables. The mean mu of a random variable x, we also sometimes call expected value of x, is the weighted average of possible values of x. reflecting the fact that all outcomes might not be equally likely. This mean is it's different than what we discussed the mean at the very beginning, chapter 1. Right? Let's recall. In chapter 1, for example, if I give you a sequence, the numbers equals 1, 2, 3, 4, like this. I'll give you 4 numbers. Correspondingly, respectively, they equals 1, 2, 3, 4. What is the mean of these 4? Right? We know we add up all this together, then divided by the total number of each 1, 2, 3, 4. So that one equals 2.5. Right? So this is the mean of the sequence. We already know how to do this. Now, we are talking about the mean of the random variable, the random variable of x. And we cannot use this way to do this anymore. So we need to see the difference between this. For example, if you are taking 3 courses, the first course you get, for example, you get C, and that's GPA equals 2. The next one you get B, that is GPA equals 3, and the last one you get A, that is 4. What's your average GPA? 2 plus 3 plus 4, then divide by 3 equals 3. Okay, that is good. How about if you take 4 courses, the last one is also get 4. What is this? I said, okay, this one is 4 here. But you said 1 course, you get 2 courses, 1 course. One course you get 2, another course you get 3, and you have, for example, 1, 2, 3, 4 courses, you get 4. You're taking totally 6 courses. And you have 4 courses, you get 8. What is your GPA? In that case, you cannot just add 2 plus 3 plus 4, then divide it by 3. You cannot do that. Because this 4 occurs more frequently than 2 and 3. So that is the mean of a random variable. For discrete random variable x, with a probability, so we know this x, we have x1, x2, all the way to xk, and the probability, corresponding probabilities is p1, p2, and pk. What is the mean of this random variable x, of this x? The mean of this random variable x is x1 times p1 plus x2 times p2 plus x3 times p3 plus all the way to xk times pk. So x1, p1, x2, p2, all the way xk, pk, and we can write in a simple way is the sum of xi, pi, and I for all i's. What's the difference between this and here? Here, if we want to calculate correctly, but with the method we used before, we should write like this. You have 2, you have 3, you have 4, but we cannot stop. This is the one class, you have another class, you have another class, you have another class. So you have 6 total courses, you have 4, you get 8. So you need to add this, then divided by 6. Divide by 6. So add all this together, then divide by 6. That is your average GPA. You cannot just use 2 plus 3 plus 4 divided by 3. Now look at this. This one, all add up together, divide by 6. That is the GPA, the correct way to do this. If we use a distributive property, this one will be equals to 2 over 6 plus 3 over 6, 2 over 6, 3 over 6, plus 4 over 6, 4 over 6, 4 over 6, 4 over 6. We said 4 over 4 over 6. Okay, what's this? Or I can write this one. It's equals to 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 4 over 6. Now compare this one to this formula. This is x1, this is p1, this is x2, this is p2, this is x3, that is p3. For this variable x, again, we have only 3 possible values. One is 2, another one is 3, the another one is 4. You don't have any other values, 2, 3, and 4. But they have different probabilities. You have only one cos, you get 2, so that is 1 over 6. So that is the probability for P1, for x1. And the same thing for this one. So this is the probability for for the cos to get a 3. But this one, you have 4 A's, so that probability is much larger than this and this. So the probability, you have 4 here out of a total 6, so that's 4 over 6. That is the probability. And this is x3, this is P3. So this is the right way to calculate your average GPA, which is this formula. Okay? So from this example, I want to show you the difference between the means of a random variable x and the means of a sequence we discussed in chapter 1. Okay, now we have an example. The probability distribution is the value of x equals 0, 1, 2, 3. We have only 4 possible discrete values. The corresponding probability is for x equals 0, the probability equals 0.027. For x equals 1, the probability equals 18.9. For x equals 2 is equals 44.1%, and for x equals 3 is 43%. What is the mean of the random variable x? What is the mean mu of the random variable x? That's easy. We just write this one. So what I want is you need to write this formula first, then plug into numbers. So x1, so this is x1 here, x1, and this one is p1. This one equals x2, this is p2. And this one equals x3, and this is p3. And this one equals x4, and this one equals p4. You multiply, you add, and this one is the result. That is the mean of the sequence. Again, let's repeat. If I give you this sequence, I give you this random variable. I ask you to calculate the. I ask you to calculate the mean of this random variable. You cannot use 0 plus 1 plus 2 plus 3 equals 7, then divided by 4. That's equals 1.75, not equal to this. Right? Even it's equal to this, this is still not a good way to do this. So the correct way is this one. This one is not correct. Next one, we discuss a concept, a law called large numbers. That is important. It's very easy. It's very important to understand the probability. As the number of random drawn observations n in the sample increases, the mean of the sample x bar gets closer and closer to the population mean mu. What does this mean? I remember at the very beginning of the class we said, for example, if I want to approximate, if I want to know the USM student GPA, right? But I don't want to calculate the sum for all the students because that is a big number. An easier way for me to do is I choose a sample. From the following chapters, we already know this sample must be random. And also we know how to determine a random sample. Suppose I have a random sample. For example, the number of the sample equals 35 as our class. For this sample, I calculate the mean. That's easy to calculate. Add all these 35 GPAs together, divide by 35. Okay, I get a mean of this sample. But what I want is the mean of the population, which is the USM student body. How good is this approximation? For example, if I make another random sample, so have 100 students, is that approximation better than the 35 sample? Definitely yes. The law of large number says if you increase the size of the sample, then the mean of the sample will be more accurate to approximate to the population mean. Also, this one is valid for any population, not necessarily normal distribution. We don't care what kind of population it is. Maybe normal, maybe not. We only care about large numbers. We want to increase the sample size. The larger the better. The larger the sample size, the closer of the mean of the sample to the population mean. We often intuitively expect the predictability of a few random observations, but it is wrong. For example, we know if I toss a coin, the head and the tail each one get a 50% probability. Now, if I toss the first one, it is head. Then what is the probability? What it will be for the next time? Next time you may guess, okay, 50%. The first time is head, then the second time must be a tail. Or at least more probability to get a tail. Well, that is wrong. Why it is wrong? Because that 2 is not a large number. Like here, we have similar examples before discussed. Okay, the first time maybe head, then the second time maybe still a head. So that no one guaranteed the first time is head, then the second time will be tail. Even it's 50%, because 2 is not a large number. So the law of large numbers only applies to really large numbers. You may ask, what is a really large number? Well, that depends. Actually, there's no real large numbers. For example, look at this. We said the height of a woman is the average equals 64.5 inches. Now, if you take a smaller sample, then it may be less than this. You increase the sample size, the number of observations, sample size n, only for very large sample, then that the mean of the sample will close to 64.5, which is the population mean. And for smaller ones, for example, this 1, 2, 3, okay, 4, 5, 10 here, and this one is like 20 or 30. This is 50. Right? So you can see for smaller sample, smaller size of the samples, the mean of the sample will be not, in this case, it's close. It's not even very close to the population. Only very large. This one is 10,000. This is 1,000. This one is 10,000. So it's very close to the population. Okay, we discussed the mean of the random variable. Next one, we are going to discuss the standard deviation or the variance of a random variable. The variance of a random variable. The variance and the standard deviation are the measures of a spread that accompany the choice of the mean to the measure center. Right? We already know that. The variance sigma x squared of a random variable x is the weighted average, again, weighted average of a squared deviation. So the x minus mu, this is the mean of the variable squared from from its mean, mu x. Each outcome is weighted by its probability. Because the outcomes are not equally likely. As in the example, you have 1, 2, 1, 3, and you have 4 courses, you get A, so they are not equally likely. So we need to consider the probability. The larger the variance of x, the more scattered the values of x on average. The positive square root of the variance gives the standard deviation sigma of x. Here is the formula to calculate the variance of a random variable. First one, I write this one in expanded form. That will be equals x1 minus mu, mu of x, then squared. And remember before we use this one, then we plus x2 minus mu x squared, and all, then we add up together. Now we need to multiply by the probability for the first one, then times the probability for the second one, and we add all this together. So that gives us the variance of the random variable. In simple, it will be xi minus mu x squared, then times pi, then we sum for all I equals 1, 2, 3, 4, all the way. Here is an example. The probability distribution is this. We discussed this in the previous slide. The possible value for x equals 0, 1, 2, 3. The corresponding probability equals this, and this. We already know how to calculate the mean of x, which is x1 times p1 plus x2 times p2, x3, p3, x4, x4, p4, and that equals 2.1. We already know that from the last slide. And the variance here is, because this one here is this, it's mu x. We already calculated this. So what we do is, this is x1, x1 is here. So let's write this one here, minus 2.1, which is this, then square it, then times p1, p1 is here, this. So that's the first term. The second term is x2, which is this, minus mu, which is here, then square it, then times p2, p2 is here, this. Okay, then the same thing. This one is here, minus this, squared, then times this, and this one is 3, this one is here, and then square it, and then times this. If we have more, we just add all this together. Now, this one is the variance of the random variable x. The variance is sigma squared. If we are looking for the standard deviation, then we just take the square root, the positive square root of a standard deviation. That gives us sigma. That gives us sigma. Alright. We discussed the linear combination of variables before. Right? Remember, we use Fahrenheit and Celsius in that example. Now we are going to discuss this further. If x is a random variable and a and b are fixed numbers, and then a plus bx, here x is a random variable, both a and b are just constant numbers, then a plus bx is also a random variable. We can write y equals a plus y equals a plus bx. So x is a random variable, both a and b is a constant number, then a plus b times x equals y. This is also a random variable. This is called linear transformation. from x to y. If we know the mean of x, and if we know the standard deviation or the variance of x, how to calculate the standard, the mean and the variance of y? We have formulas here. We don't need to start from the definition to calculate the mean and the variance. We can directly convert the mean and the variance of x to the mean and the variance of y. The mean of this y, this equals the mean of x times b, then plus a. That's this constant a plus b times the mean of x give us the mean of y. How about the variance of y? The variance of this equals the variance of x times the b squared. There's no a. As we already know in the previous chapters, a has no contribution to the variance of the linear transformation. So the variance of x times b squared, not b squared, will give us the variance of y. So that is this. And if x and y are two independent random variables, x and y are two independent random variables, then x plus y, the mean of x plus y, so mu x plus, we consider plus first, will be equal to mu x plus mu y. If this minus x minus y, then the mean of this minus will be equal to the mu x minus mu y. We combine these two together, we call mu x plus minus y equals mu x plus minus mu y. How about the variance? The variance sigma squared x plus y will be equal to the variance of x plus the variance of y. So that is the variance of x plus y equals the variance of x plus the variance of y. How about the minus? X minus y. We cannot use a minus here. We still use plus. Because remember, positive and negative number square. Because of this square, they have the same value. Negative number, negative 5 squared equals a positive. Negative 5 squared equals positive 5 squared. Because of this square, so plus minus doesn't matter. So that is still this. So we have these two formulas here. In this example, x and y must be independent. Sometimes x and y are dependent. If they are not independent, then we are going to have a correlation coefficient. Then how to calculate the mean of x plus y and x minus y? The mean of x plus minus y is the same as this one. They are the same thing. We don't need to care about there's a correlation or not. So that's the same thing. But the variance will be different. So this will be different with this. You can see the variance of x plus y will be equal to the variance of x plus the variance of y, or that is this part, then plus 2 times r, and that r is the correlation coefficient. Because they are correlated, they are not independent, so this r will not be equal to 0. So we have r here. So plus 2 times r times sigma x, which is the standard deviation, which is this, take the square root. Then times sigma y, which is the variance square root. So this. If x minus y, then the variance of this one will be, this part is the same, this part is the same, but here we are going to use a negative. So minus 2R sigma X sigma Y. Okay? So these two formulas are for dependent event, and these two are for independent event. We know for independent, because they are independent, so they have no correlation. So that means correlation coefficient in R equal to 0. If R equals to 0 here, then this part is gone. So these two formulas actually are this. So this one is more general than this. This one is just the special piece of this formula. So you can just memorize this one. You don't need to care about this. In case the R equals 0, then this one automatically goes to 0. Next, we are going to discuss an example showing how to use these formulas. And this example is very useful. It's a real meaning. You want to invest, you have some money you want to invest. You invest 20% of your fund to T-bill and 80% to an index fund that represent all US common stocks. So one is in a treasury bill, another one is in 80% goes to the stock market. Your rate of return over time is proportional to that of the T-bill. We assume this equals X, and of the index fund, we assume it is Y, such that the return equals 20% of X and 80% of Y. Y is the stock market, X is the T-bill. And we know some fact. Based on the annual returns between 1950 and 2003, the annual return of T-bill, the mean of this X equals 5%. And the standard deviation of this one equals 2.9. Right? As for the stock market, the mean return over the years is 13.2%, and the standard deviation is 17.6. So we can see here, the T-bill is, the return is smaller than the stock market, but it's more stable, right? So less risky. The stock market, the standard deviation, the variance, the standard deviation is much larger than the T-bill. So this is more stable, this is more risky. Right? So now you do not want your investment to be too conservative, or you do not want it too risky. So you have 80% to the stock market, you have 20% going to the T-bill. So now we want to know what is your return. And we have another fact that X and Y are correlated. They are negatively correlated. That means if the stock market going up, then the T-bill possibly will go down. But the correlation coefficient is not very large. It's not 100%. It is just 11%. That means you cannot guarantee if the stock market is going up, then the T-bill will go down. It's smaller. It's a very the correlation coefficient is very small, but it's negative. Okay, now we want, this is your investment, and we want to know what is the annual return, right? The average of the annual return of your investment. From here equals this and this. We use the formulas discussed in the last slide. That will be equals to 0.2 mu x, right? Then plus 0.8 mu y. So now that is easy. We have some numbers here. Mu x equals 5%, mu y equals 13.2%. We plug these two numbers into here, we get 11.56%. So that is, if you compare this one, it is larger than the T-bill and smaller than the stock market. So it's just in between. Now, how about the variance? The variance of your investment will be equal to these two, and we know these two are correlated. There's a correlation coefficient here. So we use the formulas, the general formula equals the variance of the first part, the variance of this, plus the variance of the second part, then plus 2r and the standard deviation of the first part and the standard deviation of the second part. That is the variance. This is the variance of big X in the last slide, big Y in the last slide, and the standard deviation of big X in the last slide, and the standard deviation of the big Y in the last slide, and times 2r here. And for this one, that is 2.2x. 0.2x, remember a plus bx. So this a alpha equals 0, this b equals 0.2. So this standard deviation, if you look at the here, it will be equals to b squared times the variance of x. So that one will be equals 0.2 squared, that is b. Let me write here, this one equals b. So b squared, so this is b squared, and this one is sigma x squared, the variance. And this one, again, also b squared for the second part, and this is sigma y squared. And 2r, that is 0.2 sigma x, then 0.8 sigma y. Now we plug all these numbers. Sigma x squared equal to, sigma x equals 2.9, sigma y equals 17.6. And we plug these numbers, okay, that sigma r equals, the total equals 196 something. Then take the square root equals 14.03%. And this one is the standard deviation. Right? Now compare this the standard deviation of your investment with this T-bill and stock market. We can see this one is not as stable as the T-bill, but is less risky than the stock market because you diversify your investment. So you can see your return is in between and your risk is also in between. So the portfolio has a smaller mean return than all stock portfolio, but also less risky.